Imagine looking up at the night sky and realizing that our galaxy is a predator. Not a peaceful island of stars, not a stable cosmic structure, a predator. For billions of years, the Milky Way has been hunting, tearing apart, and absorbing smaller galaxies. And the strangest part? This isn't unusual. It's how galaxies grow. In fact, nearly every large galaxy in the universe became large by consuming others. Astronomers call this process galactic cannibalism, and right now, it's happening all around us. But to understand how one galaxy can eat another, we first need to understand what a galaxy really is. Most people imagine a galaxy as a collection of stars, but stars are only part of the story. The real giant is invisible. Surrounding every major galaxy is an enormous halo of dark matter. We can't see it, we can't touch it, but its gravity dominates everything. The Milky Way's dark matter halo stretches far beyond the stars we see in the night sky. It acts like a massive gravitational trap, and anything that wanders too close can become its next victim. When a small galaxy approaches the Milky Way, the process doesn't happen instantly. There is no explosion, no dramatic impact. Instead, gravity begins a slow execution. Over millions and sometimes billions of years, the larger galaxy pulls on the smaller one. Stars begin drifting away. Clouds of gas are stripped from their original home. Entire star systems are stretched into enormous streams that wrap around the larger galaxy. Eventually, the smaller galaxy loses its identity completely. Its stars survive, but the galaxy itself is gone. It has become part of something bigger. This process has shaped the universe from the very beginning. Shortly after the first galaxies formed, the cosmos was a far more crowded place. Galaxies were smaller, distances were shorter, collisions were common. What we see today are the survivors, the winners of billions of years of gravitational competition. And our own galaxy is one of them. The Milky Way wasn't born as the giant spiral galaxy we know today. It was built piece by piece, like a cosmic empire expanding over billions of years. Every time it consumed a smaller galaxy, it gained more stars, more gas, and more mass. Even today, astronomers can still see the evidence. Hidden within the Milky Way are the fossil remains of ancient galaxies that no longer exist. One of the most dramatic examples is the Sagittarius dwarf galaxy. Right now, as you listen to this video, the Milky Way is pulling it apart. Its stars have been stretched into enormous streams that wrap around our galaxy like ghostly scars. And surprisingly, these mergers don't just destroy, they also create. Scientists studying data from the Gaia spacecraft have found evidence that repeated encounters between the Sagittarius dwarf galaxy and the Milky Way may have triggered waves of star formation. In other words, the death of one galaxy may have helped create new stars in another, including stars that still shine today. But the Sagittarius dwarf isn't the only target. The Milky Way has other neighbors, and some of them may already be doomed. Just beyond our galaxy lie the large and small Magellanic Clouds, two dwarf galaxies orbiting the Milky Way. For decades, astronomers debated their future. Today, many models suggest that at least the large Magellanic Cloud will eventually merge with the Milky Way, another galaxy added to the collection, another chapter in a story that has been repeating for billions of years, which raises an uncomfortable question. If the Milky Way has spent billions of years consuming other galaxies, what happens when something larger comes for us? The answer is already visible in the night sky. A giant spiral galaxy known as Andromeda, the largest galaxy in our local group, containing roughly 1 trillion stars, and moving toward us right now. For decades, astronomers believed our fate was sealed. The Milky Way and Andromeda were expected to collide in about 4 to 5 billion years. Their spiral arms would distort, immense clouds of gas would collide, new generations of stars would ignite, and eventually, both galaxies would disappear into a single massive system. Astronomers even gave this future galaxy a name, Milkomeda. But science has a habit of surprising us. In 2025, new simulations using data from Gaia and the Hubble Space Telescope challenged that prediction. After running tens of thousands of models, researchers found something unexpected. The collision may not be inevitable after all. Current estimates suggest the odds are closer to a cosmic coin flip, a roughly 50% chance of a merger within the next 10 billion years. The reason? Other galaxies are influencing the outcome. Even on these unimaginable scales, gravity remains a complex game, and small changes today can dramatically alter the future. So perhaps the Milky Way will eventually be consumed, or perhaps it won't. But one thing is certain, the universe is not static. Galaxies are not permanent. Everything we see is part of an ongoing process of growth, destruction, and transformation. The night sky may look calm, but behind that silence lies a violent history stretching back billions of years. A history written by gravity, a history of galactic cannibalism, and our galaxy is both hunter and potential prey.